data warriors. Welcome back to another episode where we decode the mysteries of AWS for your machine learning journey. I'm Wisdom Bird, and today we're diving headfirst into the fascinating world of data ingestion and storage, the absolute foundation of every successful machine learning project. Now, here's the thing that drives me absolutely bonkers about most certification prep. Everyone treats data storage like it's some boring prerequisite you just have to memorize. But here's the truth bomb. Data preparation for machine learning holds the highest exam coverage at 28% in the AWS Certified Machine Learning Engineer Associate MLA-C01 exam. 28%. That's more than a quarter of your entire exam score riding on understanding how data flows through the AWS ecosystem. So buckle up, because we're about to transform you from someone who thinks S3 is just cloud storage into someone who can architect enterprise-grade data pipelines that would make Netflix engineers jealous. And trust me, by the end of this episode, you'll be dreaming in data lakes and speaking fluent ETL. Let's start with something that seems simple but trips up so many people on the exam: the 3 types of data. Think of this as your data personality test, because just like people, different data types need different treatment. First up, structured data. The perfectionist. Structured data is like that friend who color codes their calendar and has their entire life organized in spreadsheets. It's data that's already been organized into a defined schema with distinct columns and data types. Picture your typical database tables, CSV files with consistent columns, or that Excel spreadsheet your finance team loves so much. The beauty of structured data? It's immediately queryable with SQL. You know exactly what you're getting. No surprises, no chaos, just clean, organized information ready for analysis. Amazon Redshift is perfect for this type of data, providing petabyte-scale analytics with familiar SQL syntax. Next, unstructured data, the creative chaos. On the complete opposite end, we have unstructured data, the wild child of the data family. This is your raw text files, videos, audio recordings, images, emails, and Word documents. There's no predefined structure or schema. It's just a collection of information waiting for you to make sense of it. Here's what makes unstructured data both exciting and terrifying. You can't query it directly. You need to extract meaning first, create structure from chaos, and figure out how to index it before it becomes useful. But here's the kicker. This is where the magic happens in machine learning. Amazon S3 is designed specifically to handle all types of data in their native format, making it the perfect foundation for data lakes. Finally, semi-structured data. Semi-structured data is the peace negotiator between our perfectionist and our chaos agent. Think JSON files, XML documents, log files, or email headers. There's some structure there, tags, hierarchies, patterns, but it's not as rigid as a database table. This is probably the most common type of data you'll encounter in real-world ML projects. Server logs, API responses, IoT sensor data, they all fall into this category. The structure exists, but you need to do some work to tease it out and make it consistently queryable. Now that we know our data personalities, let's talk about the 3 V's that will absolutely show up on your exam: volume, velocity, and variety. These aren't just fancy buzzwords. They're the decision-making framework for your entire data architecture. Volume, size matters. Really. Volume is exactly what it sounds like. How much data are we talking about? Are we dealing with gigabytes, terabytes, or holy cow, we need a snowmobile petabytes? This directly impacts your storage decisions and processing strategies. Here's a real-world example. Companies like Bigabid use Kinesis Firehose to ingest multiple data streams into their Amazon S3 data lake, processing massive volumes of user interaction data in real time. When you're dealing with that scale, you can't just upload files through the console. You need distributed systems and parallel processing. Velocity, the need for speed? Velocity measures how fast new data is being generated and needs to be processed. Are you dealing with batch processing where you can afford to wait until the end of the day? Or do you need real-time streaming because milliseconds matter? This is where the exam loves to test you on the difference between Kinesis data streams versus Kinesis data firehose. Real-time streaming requires immediate processing capabilities, while batch processing can handle scheduled loads. Choose wrong, and your high-frequency trading application might as well be using carrier pigeons. Variety, the shape-shifting challenge. Variety gets back to our data types. What kinds of data sources are you dealing with? Maybe you have structured data from databases, unstructured emails, and semi-structured JSON logs all feeding into the same analysis pipeline. This variety often determines whether you need a data warehouse, a data lake, or the increasingly popular data lakehouse approach. AWS Glue can integrate with more than 80 data sources, making it the perfect tool for handling variety in your data ecosystem. All right, let's settle this once and for all. The eternal battle between data warehouses and data lakes. This isn't just academic theory. This decision will make or break your ML projects. Data warehouses, the traditional powerhouse. Think of a data warehouse as a perfectly organized library. Every book, your data, has been cataloged, indexed, and placed exactly where it belongs. Amazon Redshift provides this structured approach with its massively parallel processing architecture, perfect for complex SQL queries and business intelligence. The key characteristic? Schema on write. You decide the structure of your data before you store it. You extract data from sources, transform it into your predefined schema, and then load it into your warehouse, the classic ETL, extract, transform, load pipeline. This approach shines when you have structured data sources. You know exactly what your schema should look like, and you need lightning-fast complex queries. Business intelligence teams love data warehouses because they can write sophisticated SQL queries without worrying about data inconsistencies. Data lakes, the flexible frontier. Now imagine a data lake as a massive storage unit where you can throw anything and everything, and I mean anything. Raw log files, images, videos, JSON documents, CSV files, it all goes in its original format. Amazon S3 serves as the primary storage platform for data lakes because of its virtually unlimited scalability and high durability. This is schema on read territory. You store first, ask questions later. Instead of ETL, you use ELT, extract, load, transform. Load the raw data first, then transform it when you actually need to analyze it. The beauty of this approach? Incredible flexibility and cost effectiveness. Amazon S3 decouples storage from compute, allowing you to store raw data in its native format and process it with different tools as needed. Perfect for machine learning where you might not know exactly how you'll use the data until you start experimenting. The plot twist, data lakehouses. But wait, there's a plot twist. Enter the data lakehouse, the diplomatic solution that says, why choose? AWS Lake Formation, combined with S3 and Redshift Spectrum, creates a hybrid architecture that provides the performance of a data warehouse with the flexibility of a data lake. This is where the industry is heading. You get the best of both worlds. Store everything in its raw format in S3, but query it like it's a structured data warehouse using tools like Redshift Spectrum or Amazon Athena. Now let's talk about the tools that make the magic happen. Your AWS data ingestion arsenal. This is where theory meets reality and where the exam will test your practical knowledge. Amazon S3, the foundation. Amazon S3 is the best place to build data lakes because of its unmatched durability, availability, scalability, security, compliance, and audit capabilities. But here's what most people miss. S3 isn't just storage, it's the central nervous system of your entire data architecture. You can trigger Lambda functions when objects are created, use S3 events to kickstart processing pipelines, and integrate with virtually every other AWS service. It's designed for 99.9999999% durability. That's 11 nines. Your data is safer in S3 than your phone is in your pocket. Amazon Kinesis, the real-time champion. When you need to handle streaming data, Kinesis is your best friend. But here's where the exam gets tricky. You need to know the difference between Kinesis data streams and Kinesis data firehose. Kinesis data firehose enables capture, modification, and loading of streaming data into storage instances with optional backup capabilities. It's perfect for near real-time delivery to destinations like S3, Redshift, or OpenSearch. Kinesis data streams, on the other hand, gives you real-time processing with sub-second latency. If you're building a fraud detection system where milliseconds matter, data streams is your weapon of choice. AWS Glue, the data engineer's Swiss Army knife. AWS Glue began as an ETL service, but has evolved to serve a broader audience, including data scientists, with capabilities for data integration across various sources. It's not just about moving data, it's about understanding data. The Glue Data Catalog acts as a centralized metadata repository that's compatible with Apache Hive Metastore and integrates seamlessly with Athena, EMR, and Redshift Spectrum. When you crawl your data with Glue, you're not just copying files. You're creating a searchable, queryable knowledge base about your entire data ecosystem. The ETL versus ELT decision. Here's a crucial distinction that will definitely appear on your exam. ETL processes transformed data before loading it into the warehouse. ELT loads raw data first and transforms it within the data warehouse using SQL. Choose ETL when you have complex transformation logic that needs to happen before storage. Choose ELT when you want to leverage the processing power of your data warehouse and maintain flexibility in your transformations. Let me paint you a picture of how this all comes together in the real world, because the exam loves to test practical scenarios. The modern ML pipeline architecture. Companies like Depop stream events via RabbitMQ, use fan-out Lambda functions to set up Kinesis streams based on event type, and create Parquet files using AWS Glue ETL and Crawler for final analysis with Athena. This is the pattern you'll see everywhere. Streaming ingestion, temporary storage, transformation, optimized storage, analysis. Each step serves a specific purpose and can scale independently, giving you the flexibility to handle complex, high-volume ML workloads with precision. The Lakehouse pattern in Amazon Redshift Spectrum enables seamless interoperability between your data warehouse and your data lake on S3, simplifying data processing from a 4-step to a 1-step process. This architecture lets you store petabytes of raw data in S3 while querying it as if it were in a traditional data warehouse. You get the cost benefits of object storage with the performance of columnar analytics, all without duplicating data or compromising on flexibility. All right. Future AWS machine learning engineers, let's wrap this up with your exam success strategy. Remember, data preparation accounts for 28% of the MLA-C01 exam, so this isn't just background knowledge. This is the exam. Focus on understanding the decision-making framework. What type of data are you dealing with? What are the volume, velocity, and variety requirements? What's the intended use case? These questions will guide you to the right architectural choices every single time. Practice identifying when to use S3 versus Redshift, when to choose Kinesis data streams versus Firehose, when ETL makes more sense than ELT. The exam loves scenario-based questions, where you need to recommend the best approach for a given business requirement. And remember, data engineering isn't just about moving bits and bytes around. You're building the foundation that enables every machine learning model, every business insight, and every data-driven decision. You're not just storing data, you're storing possibilities. That's a wrap on today's deep dive into AWS data ingestion and storage. If this episode helped demystify the world of data architecture for you, smash that like button and subscribe for more AWS certification content. Until next time, keep learning, keep building, and remember, in the world of machine learning, great data beats great algorithms every single time. This is Wisdom Bird, signing off. All right, folks, that's it for today. If you enjoy Wisdom Bird Talks Tech, don't forget to like, bookmark, and share. Your triple support is the biggest motivation for Wisdom Bird to keep going. Got a tech topic you want to hear about? Drop it in the comments. Wisdom Bird will cover it next time. See you in the next episode, where we'll keep chatting tech, talking people, and exploring the human warmth behind AI. I'm Wisdom Bird, the super smart bird flying with you on this tech journey.